Hello student, welcome back. As we have already started with electrostatic class 12 physics, in the previous video we had learned about charge, how charge behave and what charge made up of, right? So today we're going to discuss and we're going to learn about Coulomb's law. It's a very important law, okay? Remember, the numericals based on it is very important. In most of the competitive exam, every year they have to ask at least one question. So try to understand what's Coulomb's law, how it works, what it say, okay, and what its properties. Okay. Now, as you can see, it's written that the force between 2-point charge is directly proportional to the product of the magnitude of the two charge. What it mean? The first point. The first, suppose I have made two charge here. One charge Q1 and one charge is Q2, right? And the distance between these two charges R. Yeah. So the first point said that force is the force between the two charges directly proportional to the product of the two charges, right? So force, right, is directly proportional sign product of two charge. And the second point said that inversely proportional to the square of the distance between them. So force inversely proportional to the distance between them, right? Square of the distance between them. Now remember one thing, this charge can be of same charge or opposite charge. As we have learned in the previous class that if two same charge come together, what will happen? They will repel. Repel means moving away from each other. And if two different charge, suppose positive and negative, like proton and electron, come to, what will happen? They will attract each other. Clear? So this can be same charge to opposite charge, right? Now if you compare these two equation, okay, equation 1 and 2, what will get? See, obviously force common, right? So you will get this equation, right? Clear? Now for better understanding, let me write again once more. Suppose this is charge Q1, this is charge Q2, right? So the first point said that force directly proportional to the product of two charge, right? The second point said that force is inversely proportional to the distance between them, right? The square of the distance between them, right? So if you sum up this, if you compare this two equation, what will get? You'll get this one, right? So as you know that if directly proportional sign, if you change it equal, you write one constant. So we're writing here k constant, okay? Now what is k? K is called Coulomb's constant. Okay, k is called Coulomb's constant. Okay, the one thing you have to know is that, see student, suppose as by this formula, see, if we increase these two charges, if you increase the value of these two charge, remember one thing, force will increase. Are you remembering? If you increase the distance between two charges, the force will decrease. How? See, suppose there are one charge, here is other charge, right? You can see where the distance is more. Obviously here the distance is more or not, right? So here distance more, right? Yeah. Now so you have to know that directly proportional means what? Obviously if charge increase, this will, what will happen? This force will increase. Clear? You have to know this. Clear? Now k is called what? Coulomb constant, and is, see, remember one thing, it have some value. K is equal to what? 9. I have written here 9 into 10 power 9. Can you see? 9 into 10 power 9. Clear? Newton meter square Coulomb square. How you got this unit? It's very easy. See, suppose I can write like this one, k q1 q2 f r square, right? So we're going to find out this unit, right? So f r square q1 q2. So what's the unit of force? Newton, right? What's the unit of this area, radius? Meter square, right? Now two charge square, right? Coulomb, because you know the unit of charge is Coulomb, so Coulomb square. So obviously what we can write here, n m square, it's going to go up, so minus. Clear? So this is the unit, clear, of Coulomb's constant. Clear? and its value is how much? 9 into 10 power 9. There is a fixed value, constant value, clear? So this value can be used in numericals. Is it clear? Now remember one thing, it have certain value and certain equation too. See, k by 1/4 pi epsilon naught. This is called epsilon. Okay, it's a Greek word. Okay, epsilon naught. Okay, if you evaluate this equation, if you find out this equation, okay, you'll get this value 9 into 10 power 9. Clear? Now what is epsilon naught? It's called permittivity of vacuum. Okay, permittivity of vacuum or free space. Now these things, okay, permittivity of vacuum, basically, like, you know, one chapter you'll get in electromagnetics, okay, wave. In that chapter you learn, okay, properly, and in now you understand better. See, because by this formula also, as you know that what is c is called speed of light. The speed of light is, you know, like 3 into 10 power 8 meter per second. How to find out this value? By using this equation. This equation also you'll get in electromagnetic chapter, okay? Root over u naught by epsilon naught. Clear? If you evaluate this equation, okay, you'll get this value 3 into 10 power 8 meter per second. Now what's the value of u naught? These are fixed value, okay, 4 pi 10 power minus 7, and epsilon naught is 8.85 into 10 power minus 12. Clear? So if you put these two value here, you'll get this value, the speed of light. Argument point. Similarly, if epsilon naught value 8.85 10 power minus 12, if you put here, you'll get 9 into 10 power 9. Is it clear? Now the next will be, see, your equation, this equation, okay, remember one thing, this equation, right, from this Coulomb's law, clear? This equation is only for free space. Remember one thing, this equation is only for free space. Some students get confused, okay, especially in exam. This equation is only you can use when the question is mentioned that the two charges are in free space, etc. Clear? Example. So in that case you can use this equation. But if in the question any numerical, okay, if they provide any medium other than free space, you have to use this equation. 1/4 pi, here no naught, okay, here epsilon naught is the right, here no naught, okay, this is the only difference. Clear? Are you getting? Here epsilon naught is there, here no epsilon naught. Clear? This is called permittivity of medium. Is it clear? So you have to keep in your mind that this equation will use only for free space, and this is for other medium. Supposing other medium, it can be different, it can be water, many things are the other medium, okay, where the charges are placed. Now if we divide these two equations, what will get? Obviously this will be cancelled, this will be cancelled, right? So this is the only remaining, so you'll get this value, and this is also called epsilon r, and this is k. This is also a one constant, and this k, this actually is a capital letter K, okay. This k is called dielectric constant. Now what is dielectric constant? See, dielectric constant in detail you're going to learn in chapter 2, capacitor, okay. One topic is the capacitor. In capacitor only you're going to learn, okay, clear, in detail. Is it clear? So now is it clear? Again I repeat for you that Coulomb's law said that the force between two charge is directly proportional to the product of two charge, right, and inversely proportional to the distance, square of the distance between them. If you evaluate this two equation, you will get this one, right, k. Clear? And k value is how much? This value you can put, right? So I hope you got what I'm saying. Now as I said always, if you have doubt, please contact me and to clear your doubt, okay? Now next will be your Coulomb's law in vector form. Clear? Now how to represent Coulomb's law in vector form? See, similarly it's very easy. Here same way we'll use two charge one q1 and one is q2. Clear? Now obviously, as you know that here, okay, same, I'm using same charge example. Same charge, what they will do, they will repel. Obviously the repel means they will apply some force, right, to each other, right? Remember one thing, this charge will apply some force to this charge, and this charge will apply some force to this charge. Clear? So clear. Now force, next is what? Force on the charge q1 due to q2. Are you getting my point, what I'm saying? Again, for understanding, I'm just drawing here. So this is your q1, this is your q2, right? Fine. As you know that, see, you have seen here, they apply force, some force, right? Fine. Now might be you're confused why I started citing 1 2 2 1, right? Nothing is very easy. See, listen here. See, as you see, force on the charge q1. Q1 will get the force from whom? Q2, right? Are you getting my point? Force on the charge q1 due to q2, right? So q1 will expend some force because of q2, and q2 will expend some force because of q1, right? Because, fine. Now see, which equation we're writing this one? This is columns, right? From columns law we got, right? 1 by 4 pi epsilon naught q1 q2 r square. But here why I'm writing 1 2? Because it's already written here, force on the charge q1, because we are writing the force on the charge q1, right? Who is experiencing the force? Who is experiencing the force? q1, 1, right? That's why I'm writing 1 force. And for whom? Because of q2, that's why 1 2. And if similarly what we can write for this force, see, f21, right? Yes or no? Because q2 is experiencing the force now because of q1. q2 is experiencing some force because of q1. That's why I'm writing f21. Don't get confused. Now always remember one thing, anything, okay, whenever you write anything in vector form, you have to mention you have to write the unit vector, okay? You have to write in terms of unit vector. What's the unit vector? I hope you have learned in class 11. Yeah. Now see, so like, you know, whenever you represent any in vector form, any equation vector form, you have to write a unit vector. So in class 11 you have studied about a unit vector, right? What's unit vector? Actually unit vector is nothing actually which give or which tell us the direction of any vector, right? Clear? Now so it's written here, unit clear, are 1 2 be the unit vector pointing from the charge q1 to q2, q1 to q2. This is the unit vector, this is the direction. Clear? q1 to q2. So just same you have to write, nothing to worry here. Same you have to write, just you write the unit vector. Clear? And this is called, I think in class 11 you learned, this is called cap. Unit vector is written by cap, right? Now it's 2 1. I hope I explained you why 1 2 and 2 1 you should write. Clear? Similarly, how we can write about the force experienced by this second charge by because of q1. So who is experiencing the charge now? Second, right? This, clear? So 2 I'll write first, 2 1. Clear? Same 4 pi, similar, right? But 2 1 here it will be 1 2. Clear? Now it's written here, unit vector, right, are equal in magnitude but opposite in direction. Opposite direction means what? One will be negative, right? Now obviously in Newton third law you have learned or not? So remember Newton third law said that for every action there is opposite and equal reaction, and opposite reaction will be what? Minus. Opposite reaction will be what? Minus. So when these two charge act, when do these two charge apply force to each other, there will be a reaction, right? Yeah, opposite direction. The reaction will be in opposite direction. That is why one will be minus. Clear? So equation 1 become what? Simple. You replace it, right? Clear? f12 minus 1 by 4 epsilon naught q1 by q2 r square by, clear? So 1 become minus, right? 1 become what? Minus, right? So what did it apply? It applied Newton third law. It proved Newton third law. This question already came once, okay? So for 2 marks. So study hard how, like, prove that how Coulomb's law obey Newton's third law of motion. So by this process you can write. Okay, it's very simple for 2 marks. Clear? Now your next very important topic is about electric field. Yeah, so try to understand this very easy. See, what's electric field? Now to understand this one, you have to understand first this. See, I'm drawing something, look here properly. Now suppose this is a plus q charge. Okay, now it have some, obviously it will suppose it is under like this. Okay, fine, this is the center plus q charge. Suppose here one charge, I wrote here one charge here, right? Now because of this charge will expend some force, right? Yeah, I got my point. Suppose this obviously this charge will apply some force to here. This is called electric field. Suppose electric field, yeah, means it should be like it, but just for your understanding, right? Or if I draw one charge, if I wrote one charge this side also, this charge also will expend some charge because of this, right? Clear? So this is called one electric field. So what's the definition? See, it's defined as a force that a unit positive charge would experience if placed on that point. What it means that, suppose again I repeat, what is electric field? Suppose one charge is here at the center, positive charge also. So after in that, okay, so it will have some certain force around it, right? Yeah. Suppose if I brought one charge here, obviously this charge will expend some force or not. This is called electric field. Obviously, like example, suppose one magnet is there, right? Example, one magnet is there. Suppose near that magnet, if I brought one needle, that needle will expend some, obviously, that force. Clear? That's called magnetic force. We're not going to discuss about magnetic force now. Clear? Afterwards. So similarly, this is called electric field. So electric field is what? When one charge is there, right, in the center. Alright, clear? And so if you brought one other charge near it, clear, then that other charge also will experience some force. Is it clear? Now, and also remember one thing, electric field is a vector quantity. Vector quantity means, I hope you know, which have direction, and is denoted by E vector. Is denoted by E vector. Now, third point and fourth point is very important. The charge which produces the electric field is called source charge. Now you look here, which charge is producing the electric field? This charge is producing the electric field, right? Yes or no? So this will be your source charge. The charge which experiences the effect of source charge is called test charge, TEST. So who is producing the electric field? This one, right? So this will be called source charge. And who is experiencing the this one, this force? This, right? So this will be your test charge. This will be what? Your test charge. Yeah. And this will be your source charge. Yeah. So don't get confused. Again, I repeat. What's electric field? Electric field means is a force given by a positive charge to other charge. Clear? Suppose if I brought one charge here, positive charge right here. If I keep one positive charge here, and after that again I brought some other charge nearby it, that charge will experience this force, its force. Okay, so this is called electric field, and the one who produces the charge is called source charge, and the who's experiencing the charge is called test charge. Clear? And remember one thing, electric field is a vector. Clear? Quantity. Now see, so what's the formula of electric field? We said that electric field is what? Force, yeah, experienced by the test charge. Test charge, we write like that. Okay, so this test charge is, yeah, U naught. So this is a form of electric field, force by charge, and this charge should be which one? Your test charge, not the source charge. Get my point? when you write the formula about this electric field force by charge, this charge should be test charge, not the force, sorry, source charge. Yeah. So in vector form, how to write? Easy. Just write a vector, right? Yeah. Now, how to get a unit, SI unit? It's very easy. What's the force unit? Newton. Charge unit is coulomb, right? So, all right. Yeah. So, the SI unit of your electric field is N by C, Newton by coulomb, yeah, or vol per meter. Yeah. Now see, as we know that there are two types of charge. One is positive, one is, as we know, there are two types of charge. One is positive, one is negative charge, right? So how positive charge behave? Suppose this is one positive charge. Okay, remember one thing. Positive charge, they give the electric field direction will be like that. Means electric field direction will be like that. Means going away from it, electric field. But for negative charge, electric field direction will be toward it. Clear? So positive charge, what happens? The electric field will move away from it, outward direction, and for negative charge, the electric field will be toward it, right, inward direction. Yeah. So as you can see, the electric field for positive charge outward, electric field for negative charge it will be inward direction. Is it clear? So electric, this it's all about electric field. Now next will be your this one. Listen carefully. Electric field due to point charge. So your next will be what? Electric field due to a point charge. Okay, it's very easy, don't get confused. Now see, can you see this one? This is the one, two axis I'm taking, x-axis and y-axis. Clear? And this is your, I hope what is not, you know, this one, this is source charge. Source charge means what? Which is giving out the electric field, right? And this is test charge. What is called test charge? Test charge are those who are experiencing the electric field given by the source charge, right? Now it's easy. Obviously this will given, right, the force, right, it will experience, right, see this force, right? So what's the formula? Electric field force by your charge, right? So easy. For what's the formula?